Assalamu alaikum, dear engineers, and I welcome you to the second video in this series. In the first video, we explained a brief introduction to the IEC61850, where we discussed the data model, and we have said that the physical device, it is a container. That container contains one or more logical devices, each of which contains one or more logical nodes, each of which contains a predefined set of data classes, each of which contains data. And we have said that it resembles the parent-child relationship, where you can use the example of the Windows Explorer. That's the data structure or the data model in the IEC 61850. Then we have introduced two important sections in the IEC 61850 standard. That's the sample values and the GOOSE message. The sample values being discussed in the IEC 61850-9.2, which is a component of the standard that used to define how to stream high-speed dataset samples in Ethernet packets. And we have introduced the concepts of process bus and station bus. And the other part is the GOOSE messages, which they stand for Generic Object Oriented Substation Event. And we have said that it's peer-to-peer communication in protection and control applications. To configure a GOOSE application, there are 3 steps. Prepare a GOOSE dataset, set up GOOSE control block, and specify which IEDs are going to receive those GOOSE data set. In this video, we will show how to configure the CMC 356 to publish a GOOSE message. Just simply by this output here, when I click it, I need to send a GOOSE message. So when I click it on and off, to resemble that opening and closing the circuit breaker, I want that to be translated to a GOOSE message and sent out or published on the network. Then we will configure the MiCom to receive that GOOSE message. That's going to be the main discussion of this video. Also, in this video, we need to go through the settings of the MiCom to show how it received the sampled values. So before we go to the GOOSE message side, I will get a step back to show how to configure the MiCom to receive the sampled values by doing some configuration and some settings and send those to the MiCom relay. So in the previous video, demonstrate how to stream these sampled values. So we did the configuration using this quick CMC, and if I click the hardware configuration here, you will see this unit only streams the sampled values. There's no connection to the analog part of it. As you can see here, analog outputs, 0 voltage system, 0 current system. For the sampled values, I have 1 for the voltages and 1 for the currents. That's what I demonstrated here in the quick CMC. So if I just start injecting those values, that 3 voltages and 3 currents, as you can see here, then I use the MiCom to measure those. So I just start injecting those. These values should show up here in the, as you can see here, in the measurement in the MiCom. Do it again. Yep, you can see here 800 amps at minus 30 degree. That's what I'm injecting here for phase A current. 800 amps minus 30 degree, and the voltage is 288.6 kV. This is for phase A voltage, phase to neutral, and at 0 degree. Same here. Okay. So let me start by showing the settings that we did for the MiCom relay. So I'm gonna this. I close this. Let me stop it first. Then close this. So the settings here, as you can see, this is the settings. So there are a couple folders here. First one for the system data, just the most important here, the frequency, if you want to change it to 50 or 60, in my case 60 Hertz. Then we'll go to this, just view records. This is just related to the date and time. So for the primary source PTP, that is what I'm using here. Then the configuration for the different protection functions. So enabling their first group enabled, and for the overcurrent enabled. The others disabled except for the frequency protection, where we will use it to do some demonstration about frequency protection. For other than that, just if you want to see some of those settings visible or not visible. For the CTPT, this is also important here. My system is 500 kV, so the primary of that voltage transformer 500 k, and the secondary of that transformer is just 120 volts, and it's Y connected. For the CD, I have the primary 2000 amps, and the secondary is 5 amps. That's the ratio is 400. CT ratio is 400. This is just for like disturbance records and event and the measurement setup. So I set it up to show the primary values. If you want to like use either primary or secondary values, we'll work with the primary. And the measurement reference is the voltage on phase A. This is just related for the metering. For the important for us is the IEC61850. You see this folder here. So I'm communicating using the copper link. As I said, there are two ports, fiber or copper. Usually when there are actual implementation, they recommend to use the fiber port. For IEC61850, use the fiber, but in my case I just use the copper for this demonstration. Then the logical nodes count. For this device you can have up to 8 logical nodes, but for my case I just use one of them. Then you give it a name here. This is for the SVID. So this is configured in the CMC. So as you can see here, Omicron underscore CMC underscore sample value 1. That's where we put the name for the sample value ID. This is how it's going to distinguish from different sources for sample values by this sample value ID. For the IA1, IAB1, IC1, we'll get it from logical node 1. That's where my current's going to be. Sometimes you have different logical nodes, so which gonna provide which. So for the first set, so this relay can have 5 different windings, specifically for transformer protection. These like winding 1, winding 2, 3, 4, and 5. For my case, winding 1 gonna be provided by logical node 1. For my demonstration, I don't use the other like windings, just for the simple overcurrent protection. But in the coming videos, we'll demonstrate differential protection for 2 windings transformer and 3 windings transformer. So in that case, we have to have those logical nodes defined for those currents. This is for the neutral current and also for the voltages. Also, I use the logical node 1. That's it for the configuration here. Yep. That's only the configuration you need to start receive sample values in this MiCom relay. So as we demonstrated here, that's the only we need to get the measurements showed up in the MiCom relay. I will show it up again. So I'm gonna inject it. These like the voltage signs, as you can see here, it is showed up here. And as we said, that's gonna be the VA, the voltage of phase A to neutral gonna be our a reference. That's where you see the 0 degree here. So that's it for now. Then we'll head up to the configuration of the CMC to stream GOOSE messages. So in this section, we'll have the CMC 356 get configured to publish GOOSE messages, and we'll demonstrate how we can do that. So as I said, the CMC test set that I have is licensed to stream GOOSE messages, and also I have the license for the software to configure those GOOSE messages. Let us head to the test universe. So by going to the splash screen, the modules, we'll go to GOOSE configuration. Under the IEC61850 section, GOOSE configuration. So here where you can have those GOOSE messages published, and you can just drag and drop on the inputs. But for our case, we'll use the CMC to publish those GOOSE messages using the output. We have 8 outputs, but also we can use virtual outputs as well. But for my case, I just demonstrate only one output, so I'm gonna use it. If you have more than that, more than 8 messages you need to send out from the CMC, then you can use the virtual outputs. But for our case, we're gonna use only one that's gonna send the circuit breaker status out, and we'll publish that message, and then we'll configure the MiCom to subscribe to that message. So for my case, in simulations tab, we'll add the GOOSE message here. Add a GOOSE control block. So this is the data set. So we can change the name for data set here. Next, we'll add a attribute, but this attribute gonna be Boolean. Let me remove it. So next we'll add attribute, but the attribute I want to add is Boolean. That's to resemble the on and off for that circuit breaker status. So for the 52A, it's normally open. So here we can change the name to anything like okay. Then we just drag that and put it on the output, finally output of that here. So we see here that converted false. So now that GOOSE message is connected with that output. So whatever I do with this output pin, when I click it on the CMC, the status of this message gonna change, because this is my binary output, and just click start. In the CMC, they don't have the feature to export CID file, but what they have, you can export it as XML file. So let me show you that XML file. So here's an example of that XML file where I can export and use these values or these features here. Then I can use them to configure my relay to receive this message. So after I'm done, just exit. I don't want to save that. Then I will start, so I close this. Then I will start this MCL61850, this MiCom configuration language. I just right click and new file. We'll create a new file here. Then we'll open that file. Double click on it. So MiCom S1 Agile gonna open this new window for the IEC61850 IED configuration. Then we'll go and configure the, so you see here for GOOSE publishing, so either you can publish GOOSE messages from the relay and also subscribe to GOOSE messages. So in our example now, we're gonna subscribe for that GOOSE message that being sent by the CMC 356 test set. So click on GOOSE subscribing. So we'll use this virtual input here. For that, let me the enter manual editing mode. So click on that one. So here you can see you're gonna put that MAC address, application ID, and GOOSE control box source reference. That's where we're gonna put the path. So I configured that GOOSE message. So you can see here the MAC address, the application ID, then that GOOSE message source reference. We use this one here, and the GOOSE identifier 1, and the dataset reference is dataset. That's what we configured. So as I said, all this information can be extracted from that XML file that we exported from the test set. And the configuration revision is 1, then the data object index. So if you have more than one data object in that GOOSE message, it is ordered from 1 to whatever the number of data objects you have in that message. So here I have only one message and only one data object. But if you, for example, the order of this message that I want to configure here is number 5 in that GOOSE message, then I'm gonna put 5 here. And then you need to pick the data type, but in our case it's just Boolean. And after that, then we'll hit validate the configuration. So you should see 0 errors here. It's okay if you have one warning or something. After that, you just save it and send it to the relay. So I have validated the configuration and send it to the relay. The next step, how we gonna monitor that? There are a couple ways to monitor that. Either you're gonna do some configuration in the PSL, something called PSL here. PSL is the protection scheme, or use a third-party software. So in my example here, I'm gonna use both of them. So we'll start with the third-party software. So let me demonstrate that. So I have this third-party software where I configure it to see that GOOSE message. This is the identifier for my GOOSE message, and you can find it with this like MAC address of that device. So it's gonna sniff any GOOSE publishing IEDs on the network, and it's gonna give you their MAC addresses here. Then you're gonna pick that one, then it's gonna subscribe to that GOOSE message. As you can see here, we have this GOOSE simulation 00 and it's Boolean 0. So I'm gonna use the quick CMC to see how we gonna change that. So now my circuit breaker is closed by closing this 52A. So we'll start that, and I will start sniffing here. So as you can see, it's 1 here. So 0, 1. Yeah, I keep like now it's open. You see it's 0 here. That's the red dot here. Then when I click it, it's gonna change 1, and you can see the number of GOOSE messages there. As I said, it like 100 GOOSE messages in just 4 milliseconds. So you can see here it's very fast, but so that means that output from the test set is connected to that GOOSE message. So you can see here the information in the output. As I click up and down, you can see how it changes. Hopefully that's clear to you. So let me show you the next way of monitoring that GOOSE message using the PSL. So using the PSL, I have created this PSL and I configured the GOOSE message to one LED here, just for the sake of demonstration, what you can do. So I used the LED 1 here and make it non-latched. So you can see here, this is connected to this virtual input 02, and this is resemble the GOOSE message. You can see it's yellow here. So I picked the virtual input 2. Okay. Then I need to connect to the device in the real time so I can see what's going on. So they have this feature here. You can start DDB monitoring. So I'm gonna use this feature here, but let me connect to my device first. So communication setup, all those information correct. Then we'll device open connection. Okay, so device connection open. Then we'll start DD monitoring. So either real, so this is like real time, and demo. So I'm gonna use real. You don't need to change any of that, just start monitoring here. And I will mount this, then we'll come up with quick CMC. So from the quick CMC, we'll start injecting. Then we'll, you can see here the virtual input 01. I change it from 02 to 01. Then we'll, I map it, that virtual input, to the GOOSE message that's sent by the test set. So as you can see now, this one asserted and the LED is on. So turn it off, turn it on. And as you can see, the configuration is still using the 61850. That's the only communication between the relay and the test set. So 1 here. Okay. Okay, thank you very much for watching this video. In the next video, we'll do some testing to the relay. We'll start with the overcount test for the pickup, dropout, and the timing. That's going to be the topic for the next video. Thank you very much, and see you in the next video. Take care. Bye.